about composition of functions and how to take the derivative of a composite function. So we're going to learn a new derivative rule called the chain rule. And I already just talked about all of this stuff. Okay, so don't forget, projects are pretty involved. You want to start working on it now. And don't put it off till the last minute. Okay, so we're going to learn a new derivative rule today. It lets us take derivatives of even more complicated functions, the chain rule. So basically, the chain rule says, apply the normal derivative rule, and then multiply by the derivative of the stuff, okay? The inside stuff. At this point in the semester, we don't have a good justification for why the chain rule works, so we're just going to take it on faith. At some point, I will be able to justify it for you. Just can't do it right now. All right, so I've got 3 examples here. We're going to take the derivatives of these 3 functions by using the chain rule. Okay? So the idea here is apply the normal derivative rule and then multiply by the derivative of the stuff. So here's something you already know how to take the derivative of. Y equals x to the 34th, right? So y prime, I'm going to apply the power rule. My normal derivative rule would be the power rule here. So I'm going to bring the 34 down. Copy the x, reduce the exponent by 1. And then if I were to apply the chain rule in this case, I would have to then multiply by the derivative of the stuff that was being raised to 34. All right, so what's being raised to the 34th in this function? X. What's the derivative of x? 1. Okay, so the chain rule can be applied to the regular derivative rules we already know. It's just that when you multiply by the stuff, it's a 1. Okay, so this ends up just being 34 x to the 33, because times 1 doesn't change anything. Okay. Now this one, first I'm probably going to rewrite this as 3x plus 1 to the 1/2, right, instead of a square root. Okay. And then I'm going to apply the power rule, right? So I bring the 1/2 down. So I'm going to have 1/2. Instead of copying the x like I did here, I'm going to copy the 3x plus 1. Reduce the exponent by 1 and it becomes negative 1/2. But then I still have to multiply by the derivative of the stuff. The stuff that was being raised to the 1/2, what is the derivative of that? 3. Yeah, 3x plus 1 is the stuff that we applied the power rule to. So I have to multiply by the derivative of the stuff. And that gets me my final chain rule derivative. That's the final answer, yeah. You could multiply the 1/2 and the 3, right? And write 3/2 times 3x plus 1 to the negative 1/2. In general, when you're taking derivatives, unless you have to do something with it in a following step, like unless you have to take a second derivative, just leave it unsimplified, right? I'm not trying to test your algebra skills when I ask you to take a derivative. Okay, and then this last one, I've got some stuff raised to the 23rd power. Apply the power rule to the stuff. Okay, so I'm going to have y prime is going to be 23, bring down the 23, copy the stuff, x squared minus x plus 1, raised to the 22. And then I still have to multiply by the derivative of the stuff. What's the derivative of x squared minus x plus 1? 2x minus 1. There's my derivative. Careful to include parentheses when you're multiplying by the derivative of the stuff. You want to multiply by the whole thing. Because the derivative of 3x plus 1 is 3. Right? The derivative of x squared minus x plus 1, the derivative of the x squared is 2x. No, the derivative of 3x is 3, not 3x. All right, so if we look at part C, same problem. Here's a very common mistake that's used in doing the chain rule. So let's find the mistake and try to fix it, right? So we know the real answer up here. We had brought down the 23, you copy the stuff, you reduce the exponent by 1, and then you multiply by the derivative of the stuff. What did I do here? I didn't copy the stuff. This is supposed to be the original stuff. Right? So this is a really common thing that students will do when they first learn the chain rule, is take the derivative of the stuff too soon, right? So you're supposed to copy the stuff, and then this guy should be the derivative of the stuff. So if I'm trying to take the derivative of x squared minus x minus 1 to the 23rd, the chain rule says you bring the 23 down in front, you copy the stuff, right? And then you reduce the exponent by 1. Okay, so this 2x minus 1 that I put here is wrong. I didn't copy the stuff. It's actually the derivative of the stuff that I put there. So this is wrong. I'm showing you a common mistake, right? So it should just be the original stuff goes there. And then when you multiply by the derivative, it should be the derivative of the stuff. That 2 is actually the second derivative. Okay, these are 3 versions of the chain rule. They all say the same thing. We got just an English version. To take the derivative of a composition, you take the derivative of the outside function, evaluate it at the inside. So that's the copy the stuff, right? Evaluate it at the inside. That's the copy the stuff part, right? Then multiply by the derivative of the inside function. That's the derivative of the stuff.
Don't get the inside and outside.
Yeah. So let's see. If I look at square root of 3x plus 1, let's look at that again. So the inside function is the 3x plus 1. It's inside the square root. And then we think of the outside function as the square root. The square root function. You could think of this as let g of x be 3x plus 1 and f of x be square root x. And then if you remember from algebra in the summer, right? If you had if you composed those two, that's why we call this a composition, because you can write it as f of g of x, because that means take g, plug it into f, and you would get the square root of 3x plus 1. So g is your inside function, inside of f. And this helps us explain the second version of the chain rule. Okay, this says if you want to take the derivative of f of g of x, okay, it's f prime of g of x times g prime of x. So this is like a kind of a rote formula that you can memorize if you want. Or you can say if I want to take the derivative of f of some stuff, it's f prime evaluated at the stuff times the derivative of the stuff. So this is just symbolically writing out what we just did 3 times without knowing any symbols, right? You don't have to have these at your fingertips. And then this last one is Leibniz notation. We'll do more practice with this on Wednesday. But it says that if you want to take dy dx, you can break it into 2 functions, y and z, just like we broke the original function into f and g. And you do dy dz times dz dx. And this one's kind of nice because the dz's look like they cancel. But we're going to practice more with that Wednesday. For now, I'm just going to have you practice taking some derivatives using the chain rule, right? Just like we did in the examples.